All right, for those of you that did do the Canvas assignment last night, it looked pretty good, so I'm thinking like we're okay with this content. Some of you didn't do it, so you don't have any homework tonight. I left that open. Go in and do it if you didn't do it. All right, so the first one, here's my steps. I got rid of the 11 first. The plus 11 became a minus 11 on the other side. That's right here. And then I put these two blanks for my perfect squares. This perfect square here is half of 8, and then I square that number, so 16. This perfect square here is half of negative 12, but negative 6 squared is positive 36. And then I add those two numbers to the other side. You've got to do that to both sides. And then I'm factoring. What multiplies to 16 and adds to 8? 4 and 4, or 4 squared. And what adds to 36 and multiplies to negative 12, negative 6, and negative 6. And then when I add those numbers, I get 41. So that's my completed square.
Wait, do you have to put the addition sign in the middle? I didn't do that. I just left it as
Yes, add the plus sign. I think in the homework it was just there for you, but yeah, put the plus sign. That'll separate them.
How do you know it was a plus sign or a minus?
Always a plus. There's one time where it'll be a minus, and it's the very last shape we do.
Okay.
So I'll explain it then, but for now, it's a plus. All right, next one. Got rid of the 3, so you'll see it's a minus 3 here. And then I needed to complete the square twice. For the 14, it was 14 divided by 2 squared. That's 49. And for the negative 2 divided by 2 squared is 1. So my perfect squares were 49 and 1. When I add those two things to the negative 3, I get 47. So completing the square, x minus 7 squared plus y minus 1 squared equals 47. Definitely easier to complete the square with those middle numbers being even. These next two examples, you were working with odd numbers, so what you're going to see is some decimals, all right? So add the 8, that's a positive 8. Half of 11 squared is 30.25. All right, so half of 11, 5.5. 5.5 squared, 30.25. All right, half of 1 is 0.5, so you're squaring 0.5. That's 0.25. So my perfect square for that is 0.25. I'm adding both of those things to that 8. So when I combine those like terms, I get 38.5. For the decimal ones, what's going in the parentheses is half of the middle number, right? So half of 11 is 5.5, and half of 1 is 0.5, which is why I've got those decimals in there. For the last one, I subtracted the 9, that's this negative 9. Half of 7 is 3.5, 3.5 squared is 12.25. This one was even though. Half of 20 is 10, 10 squared is 100. Okay, so I'm adding those to this side. And then the number in the parenthesis is just half of the middle term. Half of 7 is 3.5, half of 20 is 10. And this is what we did yesterday. This ties directly into what we do today. Today we're now going to take this and graph it. So we're going to graph it on an XY like coordinate plane. I think you're going to think it's really, really easy. All right? So this is called completing the square, making perfect squares. So today what you're going to do is you're going to learn how to graph circles. Okay? And what you just found on all your warm-up problems are equations of circles. Circles is a big SAT concept, so for some of you that are juniors, that might affect you. Seniors, not so much, but this shows up a lot on the SAT. So we're going to learn how to graph circles. This is in your toolkit. It's on page 2. I swear it looks more intimidating than it is. All right? So the whole unit itself is called conic section. So if you pick that apart, conic means cone. Sections means sections of a cone. In your head, when you think of a cone, you're thinking like an ice cream cone or like a party hat. But the actual geometric definition of a cone is 2 of those things. Like this is a true cone. Like double it, right? So the image you're thinking and then another one. So this is a cone. A conic section is cutting math. Okay, so when you cut a cone, you can get a few different shapes, like the net of the shape looking down on it is 4 different things, all right? So if I cut a cone horizontally, straight through, and then I look down at that image, what I'm gonna be looking at is a circle, okay? So the first image we're gonna talk about is a circle. So this first blank on your toolkit, the horizontal slice is gonna give us a circle. If I cut a cone vertically, like straight up and down, that's going to create what's called a hyperbola. You can see the image here, like when I do it upside down. It's like 2 parabolas that go in opposite directions. See, like this and this, 2 U shapes. That's called a hyperbola. The circle's created right here. This is the horizontal slice. You can see the circle right there. A diagonal slice, but not exactly parallel, is called an ellipse, which is a fancy word for oval. It's kind of circular, but it's going to be more drawn out. And then slicing it diagonally, but perfectly parallel to the line, is a parabola. Of all of the shapes on the board, you are familiar with circles and parabolas, and those are the 2 that we're going to do before spring break. Okay, so we'll stick to some more of the easier content before you're gone for a week. I don't want to throw really hard stuff at you and then have you forget it over the week. Okay, so we're going to do some pretty basic stuff before you leave. The goal would be we're going to quiz on Friday, and I talked to you guys at the end of class yesterday about how I pulled you all into my bonus block on Friday. Isaiah, I couldn't get you what we thought, right? So Friday I have you in bonus block. We'll do a practice quiz, and then you'll take the quiz. It should be really, really short. So Friday's class should be like a lot of free time. All right, we're not going to learn anything before that. All right, so today we're going to focus in on the circle, and then tomorrow we'll learn the parabola, and then Thursday we'll do some practice, and then Friday we will do a quiz on the circle and the parabola. So here are the actual equations of each conic section, which looks really intimidating. You do not have to memorize any of them. You'll have a formula sheet. The equations will be right in front of you. You just have to know what the pieces mean, okay? And the pieces, if you can see, there's a lot of the same thing. There's a lots of H's and K's, and they all kind of look the same. That's because they all do the same thing. So once you know what it does for one shape, you'll know what it does for all of them. Each shape has its own little personalized piece that we'll learn about, but in general, there's a lot of the same stuff happening, all right? You don't have to memorize these formulas. Today we're going to focus in on the circle. I think this is page 5 of the toolkit. Let me know if it's not, so I can figure out what page you need to get to. Is this 5? All right. So page 5 of the toolkit is the circle. All of the points that are a constant distance r, you probably know what r stands for if we're talking about a circle. Radius. So r is the radius of the circle. From the center. Now, the center of a circle in our formula is going to be h, comma, k. It's a coordinate point. We don't use numbers because that coordinate point is going to change. So the letters just indicate that it'll move, but you're going to have a coordinate point that you plot it on. So here's what it looks like, and if you really look at this, it looks an awful lot like your warm-up answers, right? I got an x perfect square, a y perfect square, and then just some number on the other side. So you already know how to get the general form. You just complete the square twice for x and y. You can do that. You did it on your warm-up. Now what we're going to do is graph it. Like, what do we do once the square is completed? So the center of the circle is at the coordinate point h, comma, k, where h and k are the opposite of factored form, which shouldn't be of any shock, right? When you're solving something and you have x minus 5, the answer is the opposite of that, right? So this is the same thing. If it's in parentheses, you're going to use the opposite of it. And then the radius is the distance from the center. So we already know that, right? From the center of the circle to the end of the circle is called the radius. So we'll use that to graph it. So in standard form, here's our equation. We have HK and then our radius is R. This part, not R squared, is a little bit tricky, not too much, right? So if this is what I have, example 1 says find the center and radius and graph the circle. This looks an awful lot like a warm-up problem, right? We complete the square and we get something like this. Now the center of the circle is the opposite of X and the opposite of Y. So my H is positive 2 because it's minus H, minus 2. So H is in the 2 spot. And then my K is the opposite of positive 4, which is negative 4. So the center of my circle is at 2, negative 4. I'm going to make that point on the graph. So 2, negative 4 is right here. And I'm just going to label that C so you can see that's the center of the circle. Now the tricky part is you might think the radius is 16, but in the formula it equals R squared. So this 16 is in the R squared spot, meaning that the radius is the square root of that number on the other side. So to find the radius, I want to do the square root of 16. And so the radius is 4. Everybody with me so far? All right, the radius is the distance from the center. So to get some other points on this graph, I can go 1, 2, 3, 4 over and make a point. I can go 1, 2, 3, 4 up and make a point. 1, 2, 3, 4 over, and 1, 2, 3, 4 down. Right? I'm going 4 in all of the directions that I can clearly graph, like up, down, left, right. Go 4 over from the center, so that this number is 4, this number is 4. These are all my radius, the distance from the middle to the point I created. And then your actual circle is connecting the outside stuff. That is horrible, but you guys get the idea. All right, you're connecting your outside points, and now you've just graphed a circle. And that is it. All you have to be able to do. All right, let's look at the next example. We need to find the center. So the center is the opposite of what's with the X. So here it was positive 2. What do you think it is here? There's no parenthesis. What if I made one though? What would go there to keep this the same? 0. Right? It's really X minus 0. X minus 0 is just X squared, right? So the center for X is 0 when it's not shifted at all. There's nothing with X. Does that make sense? Like there's nothing in there. But the Y does have something. So I'm going to go opposite of that and call it a positive 6. So my center is at 0, positive 6. Right there. And then you just have to remember that this number on this side is in the R squared spot. If you just want R, you don't want the square, you have to undo the square. And to undo the square, you do the square root. So I'm doing the square root of 9. So this one's going to have a radius of 3. And what that means for my actual graph is I need to go 3 in all directions. So 3 to the left, 3 to the right, 3 above, 3 below. And this circle is centered at 0, 6 with a radius of 3 all around. You okay with that one? All right, what do you think the center is for C?
0, 0.
0, 0. I've got no shift here. If I were to rewrite this, I could do X minus 0 squared plus Y minus 0 squared equals 1. And now it looks more like that form. But if you don't have any parentheses, then your center is 0, 0. Right in the middle. And this 1 is my R squared. So to find my actual radius, I'm doing the square root of 1, which is just 1. It's a really small radius. So I'm just going to go 1 left, 1 right, 1 up, 1 down. And this is a really small circle. This is called the unit circle. We will learn a lot about the unit circle at the end of the semester. You will do, it'll be the only unit that moves without a calculator. Okay, but we're not there yet, we're just graphing it as a circle.
We have to create it at a square root and then we equal to.
No, you can just write 3.
Okay.
I'm just doing it for your notes because it's the first time you've seen it. All right, last one is just a little different, and that's because your radius isn't a perfect square. All right, everything else about it's the same. So my center, opposite, -3, opposite, -5. So my center is at -3, -5. Left 3, down 5. All right, my radius is the square root of 8, because this is, now for the purposes of the assignment, you're gonna write that in what's called simplified radical form. Square root of 8 can reduce, and so you need to reduce it, right? So what perfect square goes into 8?
4 and 2.
So I can write this as root 4, root 2, or 2 root 2. You are gonna write 2 root 2 in the blank. However, I'm gonna guess that most of you don't know how to graph a radius of 2 root 2. So what we're also gonna do is estimate this in decimal form, but just know this is not the actual radius, it is an estimate. So you have to keep 2 root 2 as your radius, but when you go to graph it, you're gonna estimate it at about 2.8. So just like right before 3 units. So I'm gonna write 2.8 here as an estimate, which is gonna help me graph, but it's not the radius. The radius itself is 2 root 2. You've got to include that part. So I'm gonna go just before the 0, so just before 3. I'm just estimating the 2.8. It's not perfect, especially on my board. But you wanna go about 2.8 over, above, left, right. And that is how we graph a circle. It's pretty easy. Can you believe that this is calculus, right? Pre-calculus. Some really easy stuff. All right, the only other thing that you might have to do is complete the square, which you already know how to do, right? So it says, prove that the given equation is a circle and then find its center. So the reason that this is considered a circle, you'll know it's a circle if you have an x squared and a y squared. An x squared and a y squared. Or the numbers match. If you have like a 5x squared and a 10y squared, that's not a circle. That's saying my distance for my x is different than my distance for my y. And now that's an oval, because it's going to be more long than tall. Does that make sense? So this is like my radius in my x direction is the same as the radius in the y direction. And same thing here with the 5s that match. If those numbers are different, it is a different shape. So you've got to pay attention to that. If you have 2 squared terms, x and y, and both of them have the same coefficient, you're looking at a circle. Okay? The standard form of a circle looks like this. You don't have to have it memorized. X minus h squared plus y minus k squared equals r squared. So what we have to do is manipulate this to look like that. And the only thing you have to do to manipulate this to look like that is to do the complete the square method. Just like you did on your warm-up. So I would add 11. I'm going to rearrange my order here so that my x's are together, and then I'm going to leave my blank for my perfect square. I'm going to rearrange my y's so that they're together, and I'm going to leave a blank for my perfect square. And on this side, I'll have my 11 and my 2 blanks. What's that first blank number? What's the perfect square that completes the 6? It's 9. All right, and what perfect square completes 8? 16. 36. So we've got, remember the sign stays the same, so if this is a plus, and half of that is 3. the sign stays the same, so if this is a plus, this is a plus, and half of that is 4. And when I add that all, I get 36. So this is called the standard form of a circle. X, H, Y, K, R squared. And then it just becomes a problem similar to the ones that we were just doing. The center of this circle is the opposite of positive 3 and the opposite of positive 4. The radius of the circle is the square root of 36, which is 6. And so to graph it, I'm going over 3, down 4, and then 6 in all of the directions. So these problems really are just connecting the concept from yesterday with the concept from today. You okay with that one? All right, next one. I'm going to do my x squared minus 10x plus my perfect square, y squared plus 5y plus my perfect square, and then I'll have negative 2. And I'm going to be adding 2 numbers. Negative 2 because I'm subtracting the 2. My perfect square here would be 25. Half of negative 10 is negative 5. Squared is 25. Now for this 5, it's going to be a decimal, and that's okay. So I'm going to do 5 divided by 2, and I'm going to square that number. So I've got 6.25 here. And then I'll do plus 25 minus 2 to bring that all together. So my radius will be 29.25. So complete the square is x minus 5 squared plus y plus 2.5, half of 5 squared. So when I go to actually graph this, there's going to be a lot of estimating because of the decimals. The center would be opposite of minus 5 and opposite of positive 2.5. Somewhere down here. And my radius is going to be the square root of 29.25. I can't simplify that in terms of like finding a perfect square that goes into it, because I don't think there's going to be one with that decimal. So you can just leave it like that. You are going to want to estimate it for yourself so that graphing it becomes a little easier. So it's about 5.4, a little bit under 5.5 when you're estimating where you're going. I think this one's even a little off the graph, right? Unless I'm looking at that wrong. 1, 2, 3, 4, 5.4. 1, 2, 3, 4, 5, 4. You're just making sure that you're estimating going 5.4-ish over, up, left, right. And that'll give you your circle. The only new step to a problem like the last one is this. Then it's the same problem. Just divide out the 5. Work with all of these numbers without their 5s. So now I'm looking at x squared plus y squared minus 4x plus 6y minus 2 equals 0. And now it's the same problem that you've been doing without the 5s. You don't even need to take the 5s into account when you're graphing it, right? The 5 is just gone, okay? So If I complete the square here, my first perfect square will be 4. My second perfect square will be 9, and I'll do 2 plus 4 plus 9. So standard form will be minus 2 squared plus 3 squared. That's a 15. I can get it to fit. And if I combine the 9, the 4, and the 2, that's 15. So this is a circle with a center of 2, -3, and a radius of the square root of 15. If that could simplify, then I would want to do that. But 15 isn't divisible by any perfect squares. So I'm just going to leave it as the square root of 15. And then I'll estimate the square root of 15 as 3.9 when I'm going. So just about 4 when I'm going to graph it. This is so hard to do on these. I don't even have bad vision. I can't do it on these little bits, but you guys get the idea. 3.9 over, down, left, right, all the way around, and then you can connect it. That's it. That's all we're doing today. So, practice for you for the rest of class. 28 minutes, okay? Do as much of it as you can. The answer key is on Canvas. So in your workbook, practice for circles. Page 3 and 4, you must do 1 and then 2A through D. You can do 2E and F. Your answer key is posted on Canvas. I'm happy to sit with you if you need help with any. Otherwise, you're just self-paced here. I don't want to do more than 1 shape a day because I think that that's too much, even though I think you can handle it. So I'm going to hold off on parabolas till tomorrow. Let me know if you have questions.
We're still holding on my parabolas. Can I just do it after school?
That's probably, unless you want
I
to
can, like,
do
I can
parabolas ahead of time, that's up to you.
I'll just wait.
Okay.
I can study it.
Okay.
Everything's gonna be on Canvas, right?
It'll all be on Canvas. I think you'll find the only thing that you're gonna be here Thursday, you're not gonna be here Friday, right? Is that what it is?
Yeah. Are we just calculating the parabolas in the graph with the maximum and minimum?
We actually will not use the calculator